So, good afternoon, dear friends. We have already spoken about soaps and detergents in the previous video. So, in the previous video, just to have a brush up on what happened, we spoke about fats, we spoke about oils, and then we spoke on the relation of fats, oils, and what are triglycerides basically. Because fats and oils are triglycerides. Then we spoke on why fats are solids, why oils are liquids, and then we came to the concept of what are fatty acids. So what are the contents of fats and oils also we had previously discussed, right? To explain triglycerides. And then we spoke about saponification, where we hydrolyzed the fats and oils into soaps. So those were the discussions, and then we came to sodium salts of fatty acids being soaps. So we concluded with that in the previous session. So now what we will do is we'll continue into micelles. So what is the relation between micelles and soaps? That question comes. Okay. So micelles and soaps, the question comes whether what is the difference between a micelle and a soap? Now, in the case of soaps, we are talking about soaps to be, sodium salts or fatty acids. No, this long hydrocarbon chains and the polar ends of these fatty acids, they start aggregating. Uh, Aggregation means to form clusters. They come together to form molecular clusters. These clusters we call as micelles. But however, for micelles, they have different structures. They can have, rod-like structures. They can have ball-like structures. They can have sheet-like structures. Now, these molecules that, sorry, not, I cannot use the term accumulation. This molecular aggregation to form clusters. So here, what we are seeing is in the case of long-chained sodium salts or fatty acids, they are formed spherical clusters. So spherical clusters, they'll be only formed only when there's a minimum concentration of, the fatty acids, the sodium salt of fatty acids. Now that concentration we call as CMCs, we call them as critical micellar concentration, only beyond which you can expect a micelle formation. Okay. Now, normally what happens is, the hydrocarbon chains are, repelled by polar molecules. So you can see here, in the case of these this is the spherical micelle we are seeing. So here you can see that they have shown you the structure of the stearate ion, which is saturated fatty acid. So saturated fatty acid. So what it does is it forms a spherical structure. So now this is a spherical cluster. So we call this as a micelle. So what happens is the inner part of the micelle, this is spherical. So it's like a ball shaped. It's not a circle as you're seeing in the image, but it is spherical. So there is a three-dimensional circle or a three-dimensional ball structure. So to be more specific, so all the hydrocarbon chains are in the interior of the ball, and on the outside you have all the carboxylate anions. So the carboxylate anions interact with water, stabilizing the structure. Okay. Now the hydrophobic interactions make are more important because one thing is that they are the reasons micelles are stable. Okay. So the hydrophobic interactions between water and hydrocarbon chains that causes the formation of micelles. Now, what is the relation between micelle formation and soap? Now, you know that cleansing ability. So we were previously speaking that water was not able to dissolve non-polar molecules. So I was telling you about coconut oil, which is rubbed on your hand, which is not washed away unless you use soap. So these micelles, what they're capable of is their interior part of the micelles are able to solubilize non-polar compounds. So non-polar oil molecules can be solubilized inside the balls of the micelles. So these micelle-like spherical structures, what they can do is they can solubilize non-polar molecules in their interior sections. So this is how soap functions. So it is able to solubilize dirt and things because they are non-polar molecules which can be solubilized in the interior of the micelles. So what happens here is while the exterior of soap that is the charged part of soap, interacts with polar side of water, the interior non-polar side of the spherical micelle structure, they're able to solubilize dirt and oil-like structures. Now, however, there's a problem with micelles. Okay, although we have sodium salt or fatty acids, of course, but what happens is, no, in hard water, these micelles, they are able to, form like, aggregate like structures with calcium and magnesium. So these aggregates, they form like, something like a bathtub ring, solid molecules like structures, which destroys the micelles, and they are not able to function well in hard water. So the question came like, what sort of cleansing agents can we use in the case of hard water? So that's what when scientists looked ahead, they came into a conclusion of detergents. So that's when the need for detergents came in. So previously it was only soap. Micelles were able to solubilize dirt and bring them out, but then there was a need because of aggregates formation due to magnesium and calcium ions. Now, so that's when the need for detergents came. Now, what are detergents? So detergents is just, we call it a simple synthetic material which does not, form soap scum or bathtub rings. That is, they do not form any sort of aggregates with calcium or magnesium ions. That is the simple definition we can give to detergents. Otherwise, their function is going to be very similar to that of soap. Okay, so basically, what detergents are, they are benzene sulfonic acids. So they are sodium salts of benzene sulfonic acids, which have been used in replacement for fatty acids. So the normal fatty acids, stearate, oleate, those things that we saw in the previous case, linolate, those things which we saw in the previous case, they tend to form what we call as bathtub rings or soap scum or whatever we call that. Now, those are now being replaced in the case of detergents with sodium salts of benzene sulfonic acids. Now, these do not form, any sort of aggregates with, magnesium or calcium ions. So they function well in hard water also. So they are able to solubilize, or they form a micellar structure where they can solubilize the dirt in the interior of their molecules. And while the exterior the charged sulfonate ions, they interact with the polar side of water. Okay, so this is not an in detailed explanation on cleansing agents, but it's only the organic chemistry part of things that you can learn from what's included in your organic chemistry syllabus for your third year. Okay, so with this, I conclude the cleansing agents, that is soap, micelles, and detergents. Thank you.